So last time we have seen something quite interesting happen. It did look like the overall chipset is using much more power when ray tracing is disabled, but we have noticed that the temperatures actually started to go down when I enabled the ray tracing option, which is kinda odd, since it should be the other way around. The ray tracing option should actually be the thing to make this thing work hard, but apparently that's not the case. And today we will explore that a bit more in detail. Today I actually have a lot more things to show you. So besides the usual monitor windows that I'll be using today and the usual applications, today I'll be using two new apps that show us the CPU temperature, and one of them actually shows how much power is being used by the whole chipset, by the whole device. So the usual windows will be up and running now. This is one of the new applications that I had also used to have a long time ago. Again, all the applications here are on the Play Store. You can easily replicate the test. You can test this out yourself as well if you like. But the blue app will be used for the CPU temperature. The green application will show us the battery usage and the overall power usage by the whole device, which will be interesting because I actually expect to see much less power being used with ray tracing enabled, based on the temperatures that we have seen in the previous test. Of course, every other window here will be enabled, so it will be the usual thing. And also compared the simple system monitor with the other application. Both seem to be accurate. The only big difference is the simple system monitor shows much more detail, so I might end up using the simple system monitor a lot more often in the future, just because it shows us the temperature for every single core on the device, which I would say is definitely a lot more accurate than to show the temperature on the whole package. So what is the other thing that I wanted to show here? Oh, now I remember. Let's just do a quick little GPU benchmark, just to show you how the application here works, just to show you the power usage of the device, just to show you how this works. And the moment I click on run, this is a GPU benchmark. It only uses the GPU, and you can see that the power usage goes all the way up, which is the expected thing to occur. And I will also run one or two more tests just to verify that the moment I click run, that's when the power usage goes up. This works with should work with any device, and this will be very, very important, since it actually shows us how much power is being used by the chipset running the game, or in this case running the benchmark here. This is also one application that you can find on the Play Store. CL Peak is the name. It does do a little compute benchmark on your GPU, that shows you the float point operations and things like that. Interesting stuff, and it does show you some aspects of your GPU. 99, 100% GPU being used, perfect. Which does correlate with how much power is being used by the GPU. The GPU should technically be able to draw about 8 watts at best, which does seem to be correlating with what we have seen there with the monitor. The this option here will be enabled. We will be using the alternate performance. This unlocks the full potential of a Samsung device. This is a Samsung device, so this option in my case has to be enabled to get the maximum possible performance out of the device. And the first thing when I jumped in the battle here that I thought to myself, how the hell am I going to be able to play with all of these windows on the screen blocking my view? And I'll be honest, I barely see anything. My view on both sides are kind of blocked. Now I'm actually, this is the German tank experience right here that you see here, right? I can only see forward. That's the only thing that I am able to actually see here. But the power usage is, yeah, it's expected to be high. Expected to be as high as it is. Of course, the power usage will go up and down depending on what the device is doing. The GPU is going full speed, and the CPU temperature is 7486. We are at about, well, I mean, in my case here, from my perspective, I don't really see the watt because the bloody camera is on top of the power usage. So yeah, but it's still there though. The GPU actually did throttle. This is my mistake here. We do see some throttling here. 550 from 719. That is because I have been doing something else and I did not let the device cool down. So this is this device's performance while throttling, which is still flawless. Still flawless performance even when heavily throttling. I just love how this game runs. The CPU 79, 78, 73. The GPU is at 60, 70, which is, I guess, fine. The power usage is also still really high. And rest in pieces, Panther. I actually took the T95 thinking it would be easier to play this while recording with all these distractions on screen. But I was so wrong. I also forgot that my firing button on the left will be blocked completely. So yeah, I'm playing right now with a very, very difficult layout. So if I do miss a shot or two, my bad. It's just, yeah, I'm making this very hard on myself at the moment, but all for the test, since that's the most important thing at the moment. I mean, when we compare the temperature and my battery, the power thing there just died. Oh well. That application tends to crash for some reason. Other applications tend to work, but we did see plenty of data so far, which does confirm that the game does take quite a lot of power. Now, one very important thing to note here, this is on 120 FPS, while the game is also maxed out. On 60 FPS there is barely any heating, so on 60 FPS you can play the game indefinitely. You will not see much of, if any, heating, thanks to Vulkan support and thanks to the very well coding that the developers have done with this game. I mean, this is quite literally, at the moment at least, the most demanding game on a mobile platform, since it's using the PC game engine. It is War Thunder, and they took the models from the PC version of the game. So what they did with this game is a miracle, and I have massive respect to the developers, to Gaijin, for doing such a good job with this game's optimization. Even when my device is heavily throttling now, with my mistake because I did not let it cool down, it still gives beautiful frame rate. And the heat is actually not bad. If you watched the previous Wuthering Waves video that I've done, you will notice the CPU temperature was through the roof, the GPU was barely doing anything. In this game here, the GPU is actually doing what the GPU should be doing, rendering pixels and delivering good FPS. The CPU does also its thing thanks to Vulkan, and it's supplying the GPU to enough workload, or should I say it's actually not choking the GPU. Other OpenGL games choke the GPU and they don't let it do its job. This game does not have that problem, and it's visible. And the good thing is I actually got this map. This is one of the more demanding maps, with all the tree, all the moving grass and stuff, all the buildings. This is a very big map, and there's a lot of things going on here, and to get this good FPS, it's just amazing. It just simply put amazing. But let's see if I get some bombs in. Maybe yes, maybe not. A revenge bomber moment. And I missed. Oh well. A revenge bomber failed. Wish I did get the IL-28. That's my favorite revenge bomber. That was actually not a bad match, despite me playing with a lot of things on screen being distracted, but honestly, it was a good battle, and it was fun. So, let's go to the next battle. Now, the first battle was maximum settings with no ray tracing. Here, I will be turning on the ray tracing, and of course, will be turned on and off, and we will be looking at the power usage, since I really want to see how much of a difference is in the power used by the chipset with ray tracing disabled and enabled. Now, currently playing with ray tracing, I think it is enabled. Okay, ray tracing seems to be enabled, and we see about 8.6 watts, 8 watts, GPU going full speed, 7.5 watts, 9.4 watts. It is definitely using quite a bit of power for a little mobile chipset. 8.6 watts, 9.5 watts, that's about 10 watts, okay, we crossed the 10 watt limit, but it's around that number. Definitely not going close to 13 at the moment, which it did go in the last battle. It uses 2.5 thousand milliamp hour per, well actually, 42.9% battery per hour, that's how much it's using at this current rate. Again, impressive how accurate this little application is. It also shows you the voltage as well, also important. Voltage is also important. CPU is at 80 degrees Celsius, GPU at 71. The CPU is definitely the warmest thing on this device. That's probably because of the way it's built, but can't really do much about that at the moment. Also, recording probably also has a impact on that. Honestly, I feel like the frame rate in ray tracing now seems to be a lot more smoother than last time. Okay, time for ray tracing off. Let's see what happens now. Ooh, immediately, yeah, that went. That actually went to 11 watts very quickly. 10 watts, 11 watts, 11, still at 11, but it delivers 120 FPS. And the GPU temperature went up quite a bit. The CPU also did become a toaster, okay, 13 watts. I think this confirms what I had my suspicion. Yeah, my suspicion was correct. Ray tracing reduces temperature. You cannot make this up. Yeah, there we go. There we go. So every time my device starts to heat up, I'll just turn on ray tracing, and that's going to make the temperatures go down. So this does point to some very interesting results here, because obviously the GPU doesn't seem to be using full power. Obviously that's a huge difference in heat output, huge difference in FPS as well. There is definitely something going on behind the scenes on the device, on the chipset, that I think limits the amount of GPU power that's being used while ray tracing is enabled. I guess that's kind of a smart way to prevent the device from becoming a portable bomb in one way. In the other way, I think if I manage to somehow root this device, and if I do some custom things on it, I'm fairly sure I can move that limit up, and I'm fairly sure just by allowing the GPU to draw more power, I would be able to get more FPS and more performance out of it. That's one thing I did with my PC GPU for lols and giggles. Fairly sure I might be able to do something similar to this thing, since I can tell you there is definitely something Qualcomm did that prevents the GPU from using its full power when ray tracing is enabled. Even though it shows 100%, the other little graph there, the blue one, between the little graph below the frame rate, shows that there is a little bit more left on the GPU. I think it's running at 75 to 85% of power right now, which is again quite interesting. I'm actually very glad that I tested this out. It confirmed my suspicion. So it does indeed reduce temperature when you turn on ray tracing. That's actually interesting. That's actually interesting. Because on a desktop GPU, when you turn on ray tracing, the GPU goes berserk heat-wise, because that's when it's actually working the hardest. In this case, it seems it's being limited. Again, I need to test out more games with ray tracing to actually confirm that, whether if it's the game doing that or if it's actually on device, on the software side of the device doing something in the background. But definitely much lower power usage now. And again, you have to keep in mind, this is quite literally the most demanding mobile game at the moment. Nothing comes close to it, and ironically, the most demanding game, but at the same time, it runs the best. Other games that are less demanding run worse, and that's just the magic of a properly coded game. Sometimes actually using more resources is a good thing, since that can ensure smoother performance, which is what we see with War Thunder. I mean, I'm actually seeing more stable FPS than before. It's kind of funny to think about. Much smoother performance, I would say, than with the last test. And the power monitor crashed again. It's not insufficient RAM. I have definitely more than enough RAM on this thing. It's just the application does not like to be in the floating window, doesn't like to be in the picture-in-picture mode, and that's what's causing the crash. It works for some time, then it crashes, but I would say we have seen more than enough data so far, which is definitely very important. What is bro doing? Did that M41 really have to go in front of me? And I'm not mad, it's just I'm fast as well, and I have more armor. Let me go first. That was a good hit as well. Nice little shot in the turret. And there is one more tank over there. But first let me capture the base here. So, honestly, as I mentioned before, I am very impressed by the level of attention the developers gave to the optimization of the game. At the moment, as I mentioned before, the most demanding and the most optimized game on this platform. Nothing really comes close to it at the moment, and that deserves some respect. That's a good hit, and I'm actually glad to be playing this game. It's absolutely worth it. It's a fun game. Although today we have been testing out performance, but I'm still trying to play serious as I'm testing this out. I'm actually looking at all the different monitors while playing, so I was distracted very much throughout the recording process of this battle. It was fun though, I have to admit. It is definitely fun. And that was the 9 destroyed tanks while being heavily distracted. Maybe I should play like this a lot more. Seems like I'm playing much better when I'm distracted. Anyway, that was actually a very interesting test, and it confirmed my suspicion that the device is actually using much less power with ray tracing, which is definitely interesting. Tell me what you think about the whole test and about the result in the comments down below. I'm very curious to see what you guys think about that. And with that being said, if you would like to support me, feel free to like and subscribe. And with that being said, stay safe. As always, I'll see you next time.